Welcome back, Patriots. Let's get started on the last little bit of Unit 6. I know I said last time that that was the last lesson. I just forgot we had this small little extension. We should be able to get this done really, really quick. So the question is, why in the world does domain and range even really matter? In certain real-world situations, when we take a scenario and we try to turn that into a table or graph or equation that represents it, then we have to worry about do the numbers or values actually make sense in that scenario. So here we go. We got a function m equals 42 minus 8t, which represents the amount in dollars. And so m is our money in dollars. And then after we buy t, number of t-shirts. So when we look at this function, we got m over here on the left. We got t over here on the right along with the numbers. Which one of those is to be considered our input and which one's going to be considered our output? Well, money is over here by itself, and it looks like the t is going to be affecting things. The t is over there with the slope. So the thing that's with the slope is considered the input, and the money is considered the output. So we got shirts and money. So the way that I would look at this, our starting value, our B, is 42. So that tells me we're starting with $42. Each t-shirt costs $8. And so as I buy a t-shirt, the amount of money in my hand or the amount of money in my wallet is going down by $8 per t-shirt. So that's what this equation is designed to represent. Basically, helping you decide how much money you have left after buying T number of shirts. So let's go ahead and make a chart for this. Which value do you think I should start my it says shirts is X and money is Y. What number should I start my shirts at? What's the smallest number of shirts I could buy? Yeah, 0. Because I could always walk in the store and then just not buy shirts. I could look at them and say, no, it's too expensive. Those are ugly, whatever. I don't want them, and walk out. Okay? So then I could buy any amount. I could probably buy more than that if I really wanted to. Now, range. For our range values, the amount of money, we got to plug it into the formula. 42 minus 8 times 0. And then 8 times 0 is 0. 42 minus 0 is 42, which makes sense because that was my y-intercept. So if I buy 0 shirts, I have $42 left. Now we're going to go ahead and plug in 42 minus 8 times 1. So this is 8. 42 minus 8 comes out to $34. Buy one shirt, you have $34 left. Now, the negative 8 is our slope, so I could just start subtracting 8 on these. I don't have to do the full out formula every single time. So 34 minus 8 is going to be 26. 26 minus 8 is going to be 18. 18 minus 6 is 10. 10 minus 8 is 2. And 2 minus 8 is negative 6. Now we're going to go through and look at what do our domains and ranges actually mean here. So domain is the set of all x values in the problem, and it looks like it is the number of shirts that are purchased. So number of shirts that you bought. Now our range, as I'm looking down here, where you said that was money, it looks like the amount of money that we have left. So it's the money that you have left. Okay, now before we decide on how to write our domain and range, we got to decide on whether or not it's discrete or continuous. So, remember, continuous are things that have lines or are smooth curves. Discrete are individual points. So, the question I got to ask myself is, can this flow from one value to the next, or does it have to jump from one value to the next? And let's think about that. I can buy 0 shirts, 1 shirt, 2 shirt, 3 shirts. Can I buy 1.3 shirts? No, I can't buy 1.1. So all of the values between 1 and 2 don't make sense in this context. So I have to jump straight from 1 to 2. Therefore, this is a discrete problem. And the reason why is decimals don't make sense in this situation. Because you can't buy 1.5 shirts. Now, because that's discrete, I have got to list my domain and range as a list of values inside of curly braces. Now, before we list them, though, I want to go through and talk about, does this make, or do all of these make sense in context? And the one to look at particularly is, if you buy 6 shirts, you have negative $6 left. Does that make sense? Okay, you walk into a store with $42 in hand, and you walk up to the cashier with 6 shirts and say, I want to buy these shirts. She says, okay, great, that'll be $48. And you say, oh, well, I only have 42. What's the cashier going to tell you? Sorry, you can't do that. Are they going to say, okay, you know what? That's fine. You owe me $6. Just bring it back tomorrow. Maybe if you're like some really small hometown like general goods store and everybody knows everybody's business, maybe, but not in most situations. And so this particular thing of buying more than you have does not make sense. So we're not going to be able to use this point for our domain or our range. That's also the reason why we didn't start, or why we started at 0. Would it make sense to go up one more level and have us buying -1 t-shirts? I mean, like, you're returning a shirt, but I guess we could force it to make sense. But in this context, we're just buying t-shirts from the store, buying t-shirts from a store. No, it doesn't make sense. So our only values that'll work here are 0 to 5. So 0, 1, 2, 3, 4, and 5. And then our range numbers, remember we want to do those in numerical order. So we've got 2, 10, 18, 26, 34, and I ran to my brace there. That's a 42. So how do we know when to stop using the table for domain and range values? Well, what we said was we're looking for values that don't make sense, okay? And in this particular case, it was negative shirts bought and also negative money left over. Negative shirts bought, looking for values that don't make sense, negative shirts bought, and then negative money left over. Moving on to number 2. Now, we got a function G is equal to 24 minus 4m, which represents the amount of gallons left in the tank after its draining rate of 4 gallons per minute. So we got to look at what is our input and our output based on what we had earlier. Which one's input here? Sorry, what? Yeah, M is minutes. And my output is G, gallons. Okay, so basically we got gas in a tank. We start off with 24 gallons. There's a plug in the bottom. We pull the plug and it starts draining out and the gas level goes down. All right. So in this particular situation, we got minutes over here, gallons over here. What's our minimum number of minutes we could have in this scenario? Okay, again, let's talk about context here. Does 1 minute make sense? Does 30 seconds make sense? 30 seconds after we start draining it? Yeah. How about 1 second? No? Yeah, I mean, it's a valid time, right? What about 1 millisecond? Yeah. The instant after? Yeah, that makes sense. What about the moment I pull the plug? That actually makes sense too, because at that moment, that's when I have 24 gallons in the tank. 1 millisecond later, I got slightly less. So the beginning of it makes sense. What about -1 minute? I mean, not really. I mean, because think of what's going to happen on that graph. If I was to make the graph, what's going to happen is we start up here at 24, and then it's going to go down, and then it's going to hit here. And can it dip below 0 here? Can we have negative gallons? No. Now, also, because I've got 24 gallons in there and the tank is just sitting there, if I look at negative time, this is just going to be a flat line because it stays at 24 gallons for that entire time before I pull the plug. So does this really make sense, or do I need to worry about that in the context of this problem? No. So my minimum value here is going to be 0, and then I could go by minutes from there. Okay, range. Again, y-intercept is 24, and we're just going to take advantage of our slope and do it the easy way this time. Subtract 4 off of each side. I'm sorry, off of each value. So subtract 4 and we get 20, then 16, then 12, then 8, then 4, then 0. And if I went beyond 6, I'd be in negatives, which we already said don't make sense because of that. Okay, so our words for our domain values. Domain values are the minutes since pulling the plug. Minutes since the draining started. Okay, our range is also going to be gallons left in the tank. Before we decide on how to write those, we need to decide if it's discrete or continuous. Now, we already talked about minutes. And we already said that 30 seconds makes sense. 1 second, 1 millisecond, those make sense. How about with gallons left? Would it make sense for somewhere in there for me to have 23.5 gallons? How about 23.99? 23.99999. Yeah, that's that 1 millisecond thing, right? Decimals do make sense. And so in this case, it's going to flow from one to the next, as opposed to our t-shirt scenario, which started here and then had to jump from one to the next. So this one is going to be continuous. And the reason it is continuous is because decimals do make sense. In this situation. And I also want to point out that really, when I say decimals, I don't mean any decimal ever. If you look at shoe sizes have decimals in them. Okay? Shoe sizes have 6, 6.5, 7, 7.5. So there are decimals right here. However, are you going to be able to go out and buy a 6.1, a 6.2, a 6.100934? No. This is still a discrete situation with shoe size. So just because a decimal exists does not mean it's there. It's mean that every possible decimal is a valid number there, not just some of them. Okay, so since it is continuous, we're going to go ahead and start by writing our inequality sandwich. And this time our variable in the middle is m, because we're doing minutes. And now what's our smallest number of minutes that we could use in this scenario? 0, which is the moment we pull the plug. And we already discussed how that actually does make sense. So we need to do the equal to. Now, if we've got our biggest value was 6. And again, it can be equal to. Okay, our range, I'm going to put our gallon inequality sandwich. And what's our smallest number? 0, and that one is included. And our largest number is 24, which is also included. And then here, I'm just going to write same as above. Because, I mean, it's not t-shirts and money, but it's negative time and negative gallons don't make sense in this scenario. Sometimes they do, but. Okay. And our last bit of extension here, I want to show you something. Let's say that I had a bicycle, and yes, my bicycle drawing skills are not good. Okay. Now, let's say that I put a sensor on the bicycle wheel right here. Okay? And that sensor was to record the distance, the vertical distance from the sensor to the ground. Now, what's going to happen as the wheel turns is that value is going to go down, correct? Until eventually that sensor is right at the ground and that value is going to be 0. But then what's going to happen as the wheel continues to turn? Now it's going to go back up until this value gets greater. And so, if I was to graph that, what's going to happen is, over time, it's going to start up here, and then it's going to go down and hit the ground, and then go back up. And then if I let that wheel spin again, it's going to repeat the exact same pattern, right? And in theory, that pattern could go on forever and ever and ever. Now, let's say that this thing had a 18-inch diameter. That means it would have started up here at 18 inches. And let's say I only want to look at one turn of the bicycle. And so that would be right here. Now, what that means is my domain is limited by whatever I'm reading as the scientist or as the person doing the experiment, right? I say that I'm starting at 0 and I'm stopping it after one turn. Then let's just use a 1 there for one turn. However, my range limits itself. Okay, sorry, my domain is x is between 0 and 1. My range, well, what's the minimum value for the range? I mean, that's horizontal. What's my bottom on the box? 0. And is 0 included? Yeah, because it actually touches the ground. What's my maximum value? 18. And it actually hits 18. Now, this 18 came from the natural situation. The experiment limited the range, not the experimenter. So my point is that there are reasons why domain and range are going to actually, like why functions could not hit everything. And it has to do with whatever the scenario is that generated that particular graph or that particular equation. In this case, it's a bicycle wheel. In other cases, it's just we're graphing how high a ball flies over time. That sort of thing. So that's why domain and range actually gets limited down. But we're going to have a brief lesson, or sorry, a brief assignment over this. The assignment honestly has nothing to do with the word problems. It has everything to do with just practicing your domain and range skills. So on that, keep in mind that whenever you're writing them, let's say you're doing this sort of thing, you're going to start with your inequality sandwich. For your x and for your range, you're looking for the left and the right. Whatever this x value is, let's say that this coordinate was 2, 3, and this coordinate right here was 4, 1. You're looking for your x coordinates of your endpoints. So here I've got 2 and 4. Closed dots get an underline, open dots don't. Then if we are looking at range, we're looking at our y values. So here my 3 and my 1. And that's why we draw in the box going this direction. The smaller value goes on the left, which in this case is 1. The larger value goes on the right, which is 3. Closed dot gets an underline, open dot does not. So that's all you're going to be doing on your assignment. Remember that functions, if we have anything, or for functions, we do the vertical line test. The vertical line test, we pass a vertical line over the graph. Any vertical line, if it only touches once, then yes, it is a function. If there's ever a point where it crosses twice, then it is not a function. So I'm sorry I said that was going to be quick and it took 21 minutes, but feel free to reach out, ask me any questions if you have them. I'll also be on tutorials every morning from 8 to 8:30. You can look at Google Classroom at the head banner on top to see the code to join in. I'll see you guys after the break.